All right, so now let's take up some questions. We wrote down some properties in last one. So the main properties, I've jotted them down. So main thing to remember here is that whenever base and input they match, the output is 1, and whenever the input is 1, the output is 0, and this happens for every base. And then there is power rule, which just says that this power will come out. And then there is product rule, which says the product of inputs will break up as sum of logarithms. And then there is quotient rule, which says the quotient of inputs will break as subtraction of outputs. And then there is this cancellation property, wherein these two bases, if they match, then they cancel out each other. So we are left only with x. And if they don't match, if they are distinct, then at least we can use this property, exchange property, wherein this a and c can be exchanged. That's what is happening over here. So let's talk about this problem. Very simple problem. So we are given this equation where 4 raised to power this number, which is log 3 base 9, plus 9 raised to power this number, log 4 base 2, that is given to be equal to 10 raised to power log 83 base x, and we have to guess what is x. Right, so it's a simple problem. We just need to use the properties and simplify all these three components. So let's do that. First, let's work out what is this. So before that, what is log 3 base 9? Let's figure this out. So we understand 3 I can write as 9 square root. And then we have this property which says the power rule, which says that this p can be brought out. So that I can do here, which means this half comes out. So I have half and then log 9 base 9. And we have seen that whenever input and base match, the output is 1. So that means this is 1, so this thing is half. Which means 4 raised to power log 3 base 9, that will be essentially equal to 4 raised to power half, which is just 2. So this thing over here is 2. Now let's take the next one, this one. And for that we need to evaluate first log 4 base 2. And 4, we understand we can write it as 2 square. And this 2 under same power rule will come out. So I have 2 log 2 base 2, and log 2 base 2 is going to be 1 because input and base they match. So that is going to be 1, so we are left with 2. So this gives us 2, and thereby 9 raised to power log 4 base 2 is going to be 9 raised to power 2, which is 81. Right, so we have evaluated both these things. Now we can plug them back in this equation. So let's write it here. So this equation now becomes 2 plus 81, that is equal to 10 raised to power log 83 base x. So that just means that 83 equals 10 raised to power log 83 base x. And now we see that on this side there is number 83 present, but this is sitting at the top, and we would be interested to bring it downstairs, and that can be done under this exchange property, keeping b fixed. So b here is x, keeping this fixed, 10 and 83 can be exchanged, they are equal, which means this is just 83 raised to power log 10 base x. And now if I equate these two things, then we see that exponentially base is same on both sides, and here the power is 1 and here power is log 10 base x. So that means 1 should be equal to log 10 base x. And we know that 1 is the output whenever input and base match. So that means x will take value 10. Only 10 log 10 base x can be equal to 1. Right, so this gives us the value, x is 10. So that was our problem. So pretty straightforward problem, but we just wanted to discuss, we just wanted to run through the properties. So that's very important to get used to these properties. So we'll see more serious problems on logarithms as we go ahead. For now, this just gives us a glimpse of how the properties are to be used. Well, that's finished off this problem. See you tomorrow. Bye-bye.